Hello everybody, welcome back to this video lectures and on decision analysis, and now we are in chapter 6, appendix A, calculations. So this is, we explain the code how the sensitivity analysis or sensitivity picture, this is calculated. And this is a repetition, of course. We have seen these kind of calculations before many times, so we go through the code very quickly just to remind you how to calculate sensitivity pictures like this. So the calculations are here in the lecture notes and they can be downloaded via this link, so you can use it yourself and you can use it as a template for your own codes if you want to, or you can just download it for fun. So what do we have here? As always, we have a big comment block that explains what we are doing. So this is copy-pasted from the lecture notes more or less, so I will not go through this. Just remind here, this note that this file uses functions dmatrix and scaling as almost all our, our codes use, so you should have these in your Octave working directory. And then what is next? We start with the problem data. So data basically is the decision matrix. So this decision matrix R, these are the numbers from the lecture notes. So these are the changes in GDP in percentages. Then we have the decision problems. So we have actually two decision problems. We have the decision problem for the value function Hurwitz and decision problems for the expected value function. And we call them slightly differently. Here we call it dp underscore hur and dp underscore ev. So what are the fixed fields? So these are the fields that do not depend on w or p0. So for the Hurwitz, it's the decision matrix dp underscore hur dot dmate equals r, and d rule is Hurwitz. Note the capital H here for hur. For the expected value, we have decision problems underscore expected value dmat equals the same r, but the d rule is expected value. And so what are the fields that we still need? We need the w for the Hurwitz rule, so the degree of optimism, and we need the p0 or the vector p for the expected value rule, and these we have to give in a for loops. So next let us have the for loops. So we have a sampling frequency as always for the role for the for loops, and now it says that for n equals 500 the calculations take about 30 seconds. I'm not sure if it takes that long. Let us actually see. So I start my GNU Octave. I go to the working directory. For me it's work, teaching, almost 2020 n. And let's see what is the file. File name is example underscore cc. So I tick, I start clock, example cc, and I take the time. So this will calculate the picture. So tick starts a clock, example cc, I call the function, and doc shows me the time. So it certainly is taking some time. So okay, 28 seconds, and I got this picture. And it seems that it works. Fine. All right, let's get back to the notes. So what I have here, as always, I have basically copy-pasted the problem description. Sorry, I already explained this. So I'm now here at the for n equals 500, the calculations take 30 seconds, so that was correct. And so what do we have here? So we have seen this many times before. So I have I loop for x-axis. So this is the P0 samples. I take P0, what it is, P0 samples at point I. Q0 is 1 minus P0. Decision problems underscore EV. So this is now the expected rule probabilities will be these. They are given in the lecture notes. Again, always note that for the probability, I need the comma, sorry, not comma, but a single quote to make this a column vector. Then I solve the dp underscore ev with D matrix, and the solution will be dr, decision result, expected value rule. Then I call v expected value. I could call them v1 and v2, but now I decided to call a v underscore expected value ev with the scaling. So I take the decision result ev d values. So this will be the value function for the decision result ev, and I scale them. So this will be the ev. Then for the inner loop, j goes from 0 to v sample. So now the w here is not the combination rule, but this is the degree of optimism for the Hurwitz rule. So w is w samples j, and then the dp underscore hur. So this is the Hurwitz decision problem. O degree is the degree of optimism. It will be w. Now I have all the fields I need for the Hurwitz rule, so I can solve the Hurwitz problem. So dr underscore hur is the D matrix dp underscore hur. So now it's solved the Hurwitz rule. So the Hurwitz value function v underscore hur would be the scaled values of dr underscore hur d values. So now v ev and v hur are both on the interval 0, 1. We can combine them. So v is 0.1 half times their sum. I've written it in this form now. It doesn't matter, 0.5 times this plus 0.5 times this. This is the same thing. I don't know why I wrote it this way, but it's the same formula anyway. And then we take the maximal index. So we take the maximum of v. The maximal value goes to temporary variable that we don't use, and the maximal index goes to zji. Okay, so this is what we have seen before many times. And what we have next, we have drawing the picture. This we have seen many times also. So contour F, P0 samples for the x-axis, W samples for the y-axis, and Z are the values that to be plotted. Then I set the get current axis font size 24. So this will make the labels on the axis bigger. X label will be P subindex 0. Y label will be W. So these draws the labels. Then red, green, and yellow are RGB coded like this. Then the color map will be green, dark green, yellow, dark red, and red. 1, 2, 3. So there is 1, 2, 3, 4, 5 values, but there will be only 4 values in the picture. So this dark red won't occur because we have 1, 2, 3, and 5 are the only values in the matrix Z. And then the areas, again, this I looked at the Z matrix or trial by error from the picture. So what are the X values and Y values where I place the labels A1, A2, and so on. So these text here produce these here. So this is the text for A1, text for A2, text for A3, no A4, text for A5. So for example, A5 we have very small X and Y values. So let us look at how this, for example, was written. A5 is 0.01 is X and 0.03 is Y. And there I put the label A underscore, which makes the subindex A subindex 5 with the font size 24. So that was the code. So I hope that by now you should be able to write these kind of codes yourself. You have seen many times, and they are always more or less the same. And next we have very small video lecture about what was dishonest about this example. See you there. Bye.